to force and motion. Let's recap it. Last class we have seen about many objects which tells about motion and rest, and we have seen about the introduction of motion and rest, what is motion and what is rest, and we also read about some activity about push and pull for motion. The next thing is what is called motion and rest. We have been discussed with a small story with a narration of two friends discussing in the bus stop about traveling of bus with their friends, whether moving or at rest. So the discussion is going on like whether they have been traveled or not. Then we also gone about some situations in that which is pull, which is push, which is rest and which is motion. So there are some three events we have been seen in that area where they have been taken, and also we take a case study of about a book at rest. Is it really in motion, and what is the definition for motion, and also some activities regarding the motion. Motions like moving of moon in the clouds and stars in the night and pushing of ball and lifting of water like that. And also we have been telling about inanimate objects and animate objects, and also we discussed about contact and non-contact forces, bringing of magnet activity by which we can able to understand the non-contact forces, and also the classification of forces and their examples, and non-contact forces and contact forces and their examples, and the flow chart. Some major examples like balloon crushing, batsman hitting, a cart is pulling, like that. And also the definition for forces, types of motion with an example of rotating a pencil with axis, and other things like curvilinear motions, periodic and non-periodic motions, and classification of motions in which linear, curvilinear, circular like examples has been done, and oscillatory motion with an activity of a bee. Other activities like what are the motions we can able to be identified, and also learned about speed versus slow, and what is the difference between the speed and its flow, and oscillatory and periodic motions, and revolution of a moon an example, and swinging of a child example, and waving of a tree examples. All these things comes under which kind of motions. And now we have been going for average speed, and how to calculate average speed with car, bus and a van is been explained in this chapter, and what is the formula for average speed is also been done with an example, and also we calculated here one or two problems how to calculate average speed is also been discussed. This is the second video which we are going to continue from the first part. Watch carefully and learn well. Welcome back to the unit Force and Motion. In this chapter, we are going to see about fast and slow. What is fast and what is slow, and some of the calculations to calculate the speed. And there is a small game which I will be telling you in this lesson of how to calculate our speed. And we are also going to see about computing the numerical problems. Then we will be seeing about motion and its types, and also we are going to see about multiple motions. After that we will be learning about science today under the topic robots. So what can robots do? How do robots sense? Can robots think? Artificial intelligence, nanorobotics, etc. can be learned from this part. Also we are going to see an activity, simple spin up. How to do this activity and why we need to do this activity can be learned. What are the points can be remembered from this lesson is also been told here. And we are also going to see about ICT corner. How we can learn the force and motion in an interactive way can also be learned from this lesson. Let us calculate. A cat traveled 150 meters in 10 seconds. What is its average speed? So we want to write the formula. Then distance traveled is equal to 150 meters divided by the time taken is equal to 10 seconds. So you need to divide. The answer will be 15 meters by second. Priya ride her bicycle 40 kilometers in 2 hours. What is her average speed? Again we need to write the formula, and after that we need to calculate the measurements. 40 kilometers divided by 2 hours, which is giving the answer 2 kilometers by hour. If we denote the distance in kilometer and time in hour, then the unit of average speed is kilometer per hour. Sometimes we use units like centimeter per second. In science, we generally use SI units. In SI units, the unit of distance is meter and the unit of time is second. So, the SI unit of average speed is meter by second. Let us play a small game. Go to the playground with your friends. Mark 100-meter distance for a race. Conduct a friendly running race and calculate the time they taken to complete the distance by stopwatch. Now, fill up the table. So, in the lockdown, you can use this as a game, and by means of your phone, it is having its stop clock. You can able to calculate the average distance, and you can able to identify who is running fast. Usain Bolt crossed 100 meter in 9.58 seconds and made a world record. If we have a hope to run in a speed above that speed, then Olympic gold medal is waiting for you. Okay, go children, go and play in the playground and identify who is running fast. Okay. If you know the speed and time taken by the object traveled, then we can compute how much distance it had traveled. Speed is equal to distance traveled by time taken. S is equal to d divided by t. S is equal to d divided by t, or st is equal to d. Therefore, the distance traveled is speed into time. If a ship traveled at a speed of 50 kilometers per hour and it sailed for 5 hours, how much distance it has traveled? S is equal to 50 kmph, t is equal to 5. Therefore, S into t is equal to 50 kilometers per hour into 5 hours, that is equal to 250 kilometers. If we know the speed and distance traveled, we can compute the time taken. S is equal to d divided by t, that is t is equal to d divided by s. Time taken is equal to distance traveled divided by speed. Suppose a bus travels at a speed of 50 kilometers per hour and has to cover a distance of 300 kilometers. How much time it will take? T is equal to d divided by s, that is 300 kilometers by 50 kmph, that is equal to 6 hours. Compute the following numerical problems. Number 1. If you travel 10 kilometers in 2 hours, your speed is dash kilometer per hour. This problem is solved by S is equal to 10 kilometers per hour, T is equal to 2 hours. Therefore, S into T is equal to 10 kilometers per hour into 2 hours, which is equal to 20 kilometers per hour. Problem number 2. If you travel 50 kilometers in 1 by 2 hours, you would travel kilometers in 1 hour and your speed is dash kilometer per hour. S is equal to d divided by t, which is equal to 5 divided by 1 by 2, which is equal to 5 into 2. That is 2 will come up by means of cross multiplication, that is 15 into 2, that is 30 kilometers per hour. Problem number 3. If you run fast at 20 kilometers per hour for 2 hours, you will cover dash kilometer. S is equal to d divided by t. S into t is equal to d. 20 into 2 is equal to 40 kilometers. So you will cover 40 kilometers. Uniform and non-uniform motions. Suppose a train leaves Tiruchirappalli and arrives at Madurai. Is a train travelled in an uniform speed? First, the train was stationary. When the train left the station, the motion was slow, and only after it left some distance that it gathered speed. After that, it slowed down while crossing bridges and stopped at intermediate stations for passengers. Finally, as the train approached Madurai, again it slowed and finally came to a halt. That is, the speed was not same all through the journey time. that is, the speed was non-uniform. This motion is said to be non-uniform motion. However, in between the journey, there may have a stretch where in the train might have been going at a constant speed. During that interval, the train was moving at uniform speed, that is, uniform motion. If an object covers uniform distances in uniform intervals, then the motion of the object is called uniform motion. Otherwise, the motion is called non-uniform motion. Many motions we see in our day-to-day life are non-uniform. We will learn more about uniform and non-uniform motions in later classes. Multiple motions. Look at the bicycle. What type of motion does the wheel perform? What type of motion does the cycle in total perform? The tire rotate and make a rotatory motion, but the cycle as such moves forward in a linear path. In a nutshell, we can classify the motion in terms of A. Path, B. If it is periodic or not, C. If the speed is uniform or not. However, in real life, the motions are combinations of many types. Motions may be based on the path, based on the duration, based on speed. Based on path, it may be linear motion, curvilinear motion, circular motion, rotatory motion, oscillatory motion and zigzag motion, which is called as irregular motion. Based on duration, it may be of periodic motion or non-periodic motion. Based on speed, it may be of uniform motion or non-uniform motion. See this person, he is having one swinging machine. He is asking, my machine has many of the motions in the above chart. Can you list it them? Yes. Multiple motion in swinging machine. Motion of the needle is linear and oscillatory. It's moving up and down. No, so it is oscillatory. Motion of the wheel, which is rotating here, it is rotatory. And the motion of the footrest, it will be oscillatory. Science today. Robot. This is a bipedal humanoid robot. Robots are automatic machines. Some robots can perform mechanical and repetitive jobs faster, more accurately than people. Robots can also handle dangerous materials and explore distant planets. The term comes from a Czech word robota, meaning forced labor. Robotics is the science and the study of robots. What can robots do? Robots can sense and respond to their surroundings. They can handle delicate objects or apply great force, for example, to perform eye operations guided by a human surgeon or to assemble a car. With artificial intelligence, robots will also be able to make decisions for themselves. How do robots sense? And this is a quadrupedal military robot which is used in the military. Electronic sensors are a robot's eyes and ears. Twin video cameras give the robot a 3D view of the world. Microphones detect sounds. Pressure sensors give the robot a sense of touch to judge how hard to grip an egg. Heavy luggage built-in computers send and receive information with radio waves. Artificial intelligence. Artificial intelligence attempts to create computer programs that think like human brains. Current research has not achieved this, but some computers can be programmed to recognize face in a crowd. Can robots think? Robots can think. And this is articulated welding robots which is used in industries. They can play complex games such as chess better than human beings. But will a robot ever know that it is thinking? Humans are conscious, we know we are thinking, but we don't know how consciousness works. We don't know if robots can ever be conscious. Nanorobotics. Nanorobots are nanobots are robots scaled down to microscopic size in order to put them into very small spaces to perform a function. Future nanobots could be placed in the bloodstream to perform surgical procedures that are too delicate or too difficult for standard surgery. Imagine if a nanobot could target cancer cells and destroy them without touching healthy cells nearby. Summary. So, the overall lesson tells about motion and rest are relative. All things that are rest can be seen as in motion from a different point of view, and all motions can be seen as rest from the different perspective. Application of forces is implemented by a push or pull. Forces can be applied by animate as well as inanimate agencies. Application of forces result in motion from rest, increase or decrease in speed, change in direction and distortion of the shape. Some forces act only in contact. There are some which can even affect at a distance. Average speed is equal to distance traveled by time taken. That is, S is equal to d divided by t. The motion can be classified according to the path, periodic or non-periodic, as well as if the speed is uniform or non-uniform. Unit of speed is meter per second, that is m by s. Activity 7. Try it in your home. Enjoy by making a simple spinner. Make it by the following instructions. Cut a 2 centimeter long piece from an old ball pen refill and make a hole in its center with a divider point. Take a thin wire of length 9 centimeter and fold it into a U shape. Weave the refill spinner in the U-shaped wire. Wrap the two ends of the wire on the plastic refill, leaving enough to clearance of the spinner to rotate. On blowing through the refill, the spinner rotates. For obtaining maximum speed, adjust the wires so that air is directed towards the ends of the spinner. Have you enjoyed with simple spinner? Do you observe motions in the toy? Can you answer the following questions? Motion of the air in the tube is dash motion. So if you try it, you can able to identify that the motion of the air in the tube is in rotatory motion. Motion of the refill stick dash motion. It is in the linear motion. The toy converts dash motion into dash motion, linear motion into rotatory motion. Think. In simple spinner, linear motion is converted into rotatory motion. Can you make a toy which converts rotatory motion into linear motion? Yes, try it out. I will give you one clue. Any rolling body will be giving you a linear motion. For example, a simple car or a simple ball rotated in the floor. Now we can check ourselves by evaluating these questions that we understood the lesson. Number 1. Choose the correct answer. Unit of speed is d meter per second. 2. Oscillatory motion among the following is d all of this. The correct relation among the following is d speed is equal to distance divided by time. Fourth question. Geeta rides with her father's bike to her uncle's house, which is 40 kilometers away from her home. She takes 40 minutes to reach there. The statement 1 is she travels with a speed of 1 kilometer per minute. Statement 2 is she travels with a speed of 1 kilometer per hour. So the answer will be statement 1 alone is correct. Second one, find whether the following statements are true or false. If false, give the correct answer. To and fro motion is called oscillatory motion. Yes, we studied that. To and fro motion is called oscillatory motion. So the statement is true. Vibratory motion and rotatory motion are periodic motions. True. Vibratory motion and rotatory motion are periodic motions. So it is true. Vehicles moving with varying speeds are said to be in uniform motion. This statement is false because varying speeds means we can understand that it is non-uniform motion, so the statement is false. Robots will replace human in future. True. 3. Fill in the blanks. A bike moving a straight road is an example of linear motion. Gravitational force is a non-contact force. Motion of potter's wheel is an example of rotatory motion. When an object covers equal distance in equal interval of time, it is said to be uniform motion. Match the following. The first picture depicts C. Linear motion. Second picture, the answer is A. Circular motion. The third picture, swinging of children, is oscillatory motion. Fourth picture is rotatory motion. And the fifth picture is a car running in the road, that is linear and rotatory motion. E answer. 5. Analogy. Number 1. Kicking a ball is to contact force. Falling off leaf is to non-contact force. Number 2. Distance is to meter, is to speed, is to meter per second. Number 3. Circulatory motion is to a spinning top, is to oscillatory motion, is to swinging of pendulum. 6th. Given below is a distance traveled by an elephant across a forest with uniform speed. Complete the data of the table given below with the idea of uniform speed. The distance is equal to in meters 0, 4, dash, 12, dash, 20. Times per second is equal to 0, 2, 4, dash, 8, 10. So we need to calculate distance traveled by time taken, and we can able with the formula identify the answers. Next one is complete the web chart. Non-periodic motions, periodic motions. Again, non-periodic motion will give to movement which do not repeat after a fixed interval of time. Periodic motion, movement repeated after a fixed interval of time. Oscillatory motion gives movement around one axis or a fixed center. 8th Roman letter. Give one word for the following statements. Number 1. The force which acts on an object without physical contact with it. Answer is non-contact force. Number 2. A change in the position of an object with time. Answer is uniform motion. Number 3. A motion which repeats itself after a fixed interval of time. Answer is periodic motion. Number 4. The motion of an object travels equal distance in equal intervals of time. Answer is periodic motion. Number 5. A machine capable of carrying out a complex series of actions automatically. Answer is robot. The 9th Roman letter is answer the following in a sentence or two. So you need to identify the answers in the book and try to write it in your notebooks. ICT corner. Play with force and motion in an animated way. So what do we need to do? Let's learn force and motion on PHET in Google browser. Download and install. Drag any one side and place him in the knot portion of the rope. Now click go. If placed on the right side, then the load will move in that direction. If placed on right side, then the load will move in that direction. The place of the man and the number of men can be changed. The direction of the force and the unit of force will display on the screen. If we place equal number of men on both sides, the load will not move. By changing the number of men, the strength of the force can be changed. So it is interesting, no? Just you play it. I have given that link in the down, or scan it in the mobile phones. You can directly access the site. This is how the interactive game will be. This is how the interactive game will be. See, I am placing number of man and see what happens. So these two men are heavier than these two people, so it will be going on one side. We can able to have some motions and its video also as an interactive game. If you are giving more amount of newtons, the man is able to push the heaviest weight. Yes, he is also stopping when you are giving negative newtons. Can you able to see that? Is it interesting? This is how we can able to play the game, and we can also select four kind of values here: forces, values, mass, speed, etc. We can able to see all these things comes in the screen. And now it will also display here itself how much amount of force or kilogram we are going to place it here or given here. So we can learn from this how much speed is also in meter per second is also coming here. Okay. So by this interactive game, you can able to learn more about the force and motion. Try it and enjoy it both in laptops or in computers or even in mobile phones. It can able to be seen. Okay. Thank you students for being with me to learn this lesson. Thank you.